In this video, I want to talk about the structure of the disaccharides, which are just two simple sugars put together, two monosaccharides, and polysaccharides, which are many sugars long. Okay, so I'm just going to kind of draw them out. Starting off with maltose. So maltose is essentially, at least the way I learned it, was 1 alpha D glucose plus 1 beta D glucose. Okay, so and these two are connected via an alpha 1,4 glycosidic bond. So what does this mean? What is alpha 1,4 glycosidic bond? What does this mean? Right? We should know the structures of alpha D glucose and beta D glucose by now. Right? So if we're drawing an alpha D glucose, it's going to look like this. So glucose, right, was milk dud. If we're talking about alpha D glucose, we've got down, up, down. Right? But now, so it's going to be an alpha D glucose, so the OH would be down. But the thing is, this is not going to be an OH because it's going to be connected to the beta D glucose. Okay? And the reason why is because it's an alpha 1,4 glycosidic bond. So what is that sort of getting at? If you remember numbering the carbons, 6, 5, 4, 3, 2, 1. This alpha 1,4, the 1 refers to carbon number 1 on the first thing, which is the alpha D glucose, and the 4 refers to the second, what's it called? So if we call this molecule A and this molecule B, then this is referring to A, and this is referring to the connection on B. So when we draw the beta D glucose, it's going to actually be connected here like this. So let me actually draw it out and kind of explain it upon drawing it out. So this is going to be a beta D glucose, so it's still down, up, and then down, but the connection here occurred via dehydration synthesis. We got rid of an H and an OH, which is just the water, to form this covalent bond between the two. Okay, so this was down, up, and this is still pointing down here, right? So this is CH2OH, right? This is molecule A, right? This is A, which is the alpha D glucose, and this is the beta D glucose here. Let me fill in all these OHs here. Right, and this is a beta D glucose, so the OH on the anomeric carbon is going to be pointing up. So this here, this disaccharide, is maltose, right? 1 alpha D glucose connected to 1 beta D glucose. Now, let me go through and number these carbons here. We have 6, 5, 4, 3, 2, 1. So what are they talking about with this alpha 1,4 glycosidic bond? Well, the alpha comes from the fact that this anomeric carbon is alpha, right? And this is carbon number 1. So alpha and 1 come from molecule number 1, or molecule A, right? Now the 4 comes from the fact that we're binding this carbon here, the carbon that we're connecting to on the second sugar is right there as carbon number 4. So this is an alpha 1,4 glycosidic bond. That's the name for the bond between two sugars. Okay, so that's maltose. Next up is lactose. So lactose is 1 beta D galactose plus 1 beta D glucose connected via a beta 1,4 glycosidic bond. Right, so we're going to have an a beta D galactose and a beta D glucose. So beta D galactose look like this. Oops, I forgot the O up here on this maltose up here. There we go. Now that's maltose. So beta D galactose. So D means it's going to have this going on up here, CH2OH, down, up, up for galactose. Right, and let's number these carbons. So we've got carbon number 6, 5, 4, 3, 2, and 1. Okay, so 1 is going to be beta, which means it's going to be going up, right? So again, we're going to have loss to water here. Okay, so now this is going to be connected to the 4th carbon on the beta D glucose. So the 4th carbon on the beta D glucose would be pointing down. So it would look something like this. So this is going to be a beta D glucose. So CH2OH, down, up, down, which is why I do that connection in that fashion. Right, and this is going to be a beta D glucose, so the OH is going to be going up. Alright, so now, does this all make sense? 6, 5, 4, 3, 2, 1. Beta 1, 4. So is this a beta 1, 4 linkage? Well, this is carbon number 1, so this portion here is correct. This bond is going up, which is the same direction as the CH2OH, so this beta portion is correct. 4, is it connected to carbon number 4 on the next thing? Yep, that's correct. That is a beta 1,4 glycosidic bond, and that is lactose. Okay. Cool. Next up, we're going to draw sucrose. Sucrose is kind of funny to draw, but it's 1 alpha D glucose plus 1 beta D fructose. And its connection is an alpha beta 1,2 glycosidic bond. This is a little bit interesting. Okay, so what is this, right? So up here we had just a beta, right? Now we have an alpha beta. What does that mean? Okay, well, let's draw it and see what we can get. So when we have the alpha D glucose, well, we know what that looks like. That looks like this. Down, up, down, because it's glucose. CH2OH up because it's D. The circle up here. Oh goodness, I forgot the circle up here. The O up there too. So now this is alpha D glucose, which means that its O is going to be pointing down. Now that means, so alpha is about this carbon here, right? So this O is going to be down. Beta, so alpha and 1 kind of go together. Okay, let's see if we can make sense of this. The alpha and the 1 go together, and the beta and the 2 go together. So the alpha, or excuse me, the beta and the 2 are part of this, and the alpha and the 1 are part of this. So this is the 1 carbon. First of all, let's go back and number these carbons. So if we number these carbons, we've got 6, 5, 4, 3, 2, 1. So here, this 1 carbon is going to be alpha. That makes sense here. Okay, it's going to be connected to the beta 2 carbon on fructose. So let me draw this out because it's kind of funny how this works out. It's kind of weird. So this is going to be connected to sucrose like this. So sucrose looks, or excuse me, fructose looks like this. Okay, if it's beta D fructose, it's going to have a CH2OH like that. Fructose is up and down. Okay, and it's beta. The OH would be going up. But now let's not forget fructose is a 6 carbon molecule, right? So its CH2OH has to be coming down here. So let's just make sure that we have all those correct. 6, 5, 4, 3, 2, 1. What does this make sense? This here, this anomeric carbon, carbon number 1 is alpha. So alpha and 1 check out, right? Because this OH would have been down relative to the CH2OH opposite sides. So alpha and 1 go together. This fructose here is a beta D fructose. This OH is going up, same side as this CH2OH, so it's beta, and this is on carbon number 2. right? This is why we have this second thing here. It's not just an alpha 1,2 linkage. This beta specifies here that the linkage is it's linked to the anomeric carbon here. So this here is sucrose. Okay. One thing I wanted to point out before I moved on to some of the polysaccharides is that that these first two, maltose and lactose, they both have, at their anomeric carbon, they have free OH groups. Okay, so the fact that that H is there makes them able to reduce another compound. Okay, so because they have that free OH group there, hanging off the end, they are what's called reducing sugars. Okay, so they can this OH can reduce something else and hence become oxidized and become a carbonyl group. Okay, so these are both reducing sugars. However, is sucrose a reducing sugar? Well, its anomeric carbon, it does not have a free OH. No free OH group. So it is not a sugar, excuse me. Not a reducing sugar. Okay. Whereas these ones, they both have free OH groups. At the anomeric carbon at the end. Okay, so this goes the same thing for this one. Okay, so that's sucrose. A couple more things I want to mention. I want to mention cellulose. So cellulose is basically, it's a polysaccharide. So these first three were disaccharides, right? Just two monosaccharides put together. Cellulose is a bunch of beta D glucoses connected or linked via beta 1,4 linkages or glycosidic bond. Okay, so the way they'd look is kind of like this. If we have beta D glucoses, we'll have one beta D glucose here, CH2OH, down, up, down, beta, so it's going up. Okay, connected to another one via 1,4 linkage. So the fourth one is down, so it's going to look like this. Goodness, I keep forgetting those O's there. My apologies. Down, up, down. This is also going up. Right, and now this is going to be connected to another one, dot, 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 etc., etc., etc. But the point is here, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. The linkage here is indeed a beta 1,4 linkage. Okay. Now, so this is just a bunch of glucoses connected together, but that's also what starch and glycogen are. Starch and glycogen are also just a bunch of glucoses put together. Starch and glycogen, also just a bunch of glucoses, but specifically, they're a bunch of alpha D glucoses linked via alpha 1,4 linkages. Right, so they're going to look a little bit different. They're going to have alpha D glucoses are going to look like this. Down, up, down. If it's a 1,4 linkage, this is an alpha. It's going to go down. Going to connect to the next glucose, which is alpha, and it's going to look like this. Down, up. Right, and this is also going alpha, so that's going to be connected to the next one, right? And so dot, 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 dot. It's a long string of these. Okay, is this an alpha 1,4 linkage? Well, let's go back and number the carbons. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. So here we've got, whoops, here we've got the one carbon. It's alpha because it's the bond is pointing down, and this one's pointing up, so they're trans. This is the one carbon connected to the fourth carbon, so this is indeed an alpha 1,4 linkage, just as this was a beta 1,4 linkage. Now, humans cannot digest cellulose. We do not. Even though there's just a bunch of glucoses together, just like starch and glycogen are, we do not have the enzyme that allows us to digest cellulose. We can't digest this beta linkage. However, we can digest starch and glycogen because we do have the enzyme that breaks up this alpha linkage. Okay, so that's something to keep in mind. This is why we can eat things like rice and potatoes, right, and digest them and use them and break up those glucoses and use those glucoses for energy through glycolysis, which we'll talk about in the future. But we can't digest things like grass or paper, right? We can't digest paper. We don't eat napkins. Our bodies don't recognize those as things that we can break down for glucose. That is definitely the case. One thing I forgot to mention that I did want to go back to was that lactose is, some people are lactose intolerant. So if you are indeed lactose intolerant, it's likely that you do not have the enzyme that can break up this beta linkage. Okay, so those individuals who are lactose intolerant cannot break down that, or that don't have the enzyme lactase, which breaks that down. Okay, so I hope that overview of disaccharides and polysaccharides was helpful. I'll also post a video of the PDF that I used to kind of put this together. So I hope that was helpful.